Hi, I'm Rob, and welcome to this, our 18th lesson in the topic of trigonometry. And this one follows on from the previous two lessons that we're still looking at how to solve trigonometric equations. But these ones we're going to have a look at are a little bit more complicated because the trigonometric equations are slightly hidden from you. And you have to try and find them yourself first, right? So normally what I'm going to try and do here is I'm going to try to factorize if I can. And if I can't factorize, I may have to rearrange using a formula or an identity from my formula booklet first. So I'll show you what I mean by that. That if, for example, if you take this equation here, if you take a trigonometric equation like this one, let's say, for example, you've got 2x squared minus x minus 1 equals 0. The way we would solve that one, remember, is just by factorizing, right? So if I open up my two brackets here, like that, the factors of 2x squared are 2x by x. Factors of 1 are 1 by 1. I think I need a minus sign there and a plus sign there to give me the minus x in the middle. And then if those two things multiply together to give me 0, either that must be 0 or that must be 0. Remember, that's the principle of how that works. That in your own head, if you multiply together two things that give you 0 as an answer, you'll see that one of those two things has to be 0. You can't multiply together two things, neither of which is 0, and get an answer of 0. So the only way multiplying those together will give you an answer of 0 is if one of them is equal to 0. So we get that 2x plus 1 equals 0, or x minus 1 equals 0. And I can solve those two equations to find my values for x. Right? Now, if you can imagine the very same idea with something like this. So it's 2 times sine squared x minus sine x minus 1 equals 0. Well, clearly, that's a trigonometric equation again because it's an equation that contains sines. But it's not just sine x equals a number or sine 3x equals a number, okay? There's a combination of them here. But essentially, that's the very same as this equation here. I've just replaced letter x with sine x. It might just be worth reminding you that, remember, when you see that sine squared x, that you can't in trigonometry write down that. Because that's ambiguous. I don't know, does the square apply to just the x, or does it apply to both of them? So does that mean this, where it's sine of x all squared, the square applies to the whole thing, or does it mean this? Right? So that writing it that way is ambiguous. I don't know whether the square applies to just the x or whether it applies to the whole thing. So when this is the one we're referring to, okay, when it's the whole thing that's squared, to avoid any confusion, we write it that way. So sine squared x means this. It's sine of x squared. So you can see that there would be 2 times sine of x squared like that minus sine of x minus 1 equals 0. So notice that's the very same as this equation here, just I replaced x with sine x. So it'll be the very same idea. If I factorize this, I'll get down to two brackets like this, put them equal to 0, and that will give me two little equations like the ones we've been dealing with in the previous couple of lessons, which I can solve. So that's the idea here, slightly more complicated equations where you maybe have to factorize first. And by factorizing, you'll produce equations like the ones that we're dealing with. Now, these equations are much more difficult and they're far, far less common than the previous examples that I'd look at here. So this is kind of worst case scenario. But we'll have a look at a couple of these just in case to cover our bases. So if you look at the first one there on page 261, it's actually the one we've kind of mentioned in passing there. Okay, the one on page 261. It looks like this. For us to solve this equation here, 2 sine squared x, right? So 2 sine squared x minus sine x equals 1. So again, let's bring everything onto the same side, okay, first of all. So we've got 2 times sine squared x minus sine x minus 1 equals 0. There's the equation. Okay, so what I'm going to try and do here is factorize. That's always your first port of call. Anytime in maths you've got something equal to 0, your first option should be to factorize and then use that trick. If I can factorize the left-hand side, I can write the left-hand side as two things multiplied together. And if two things multiplied together give me 0, then one of them has to equal 0. That's always my default setting when I'm solving a tricky equation where something is equal to 0. Okay? So I'm going to try and factorize that. Now, if you can't visualize the factors there because of the sine x, just replace sine x with your favorite letter for a second. So you could say, look, that's basically the same as 2a squared minus a minus 1. So if I just replace sine x with the letter a for a moment, it might be easier for you to see the factors there. You don't have to do that, but if you want to, you can. So if I just take out sine x and replace the letter a, it looks like that. You can see, well, that's the equation we had on the board a moment ago. Okay, that's going to look like that. So it's going to be 2a by a. Factors of 1 are 1 by 1, and a minus and a plus there, because that's going to give me minus 2a plus 1a will give me the minus a in the middle. Okay? So there are my two brackets there. And now I can put the sine x back in again. So essentially I get this. I get one bracket is 2 sine x plus 1. Okay, that's if I put the sine x back in there. And then sine x minus 1. Now you don't need to do that. If you're okay seeing what the factors of this are here, you can jump straight there. But just if you have difficulty visualizing it, replace the sine x or the cosine x or the tan x with a letter and see if you can factorize it that way and then put the sine, tan, or cosine of x back in again. Okay, so there's the idea there. So I've factorized the left-hand side. And now remember, if these two things multiply together give me 0, either that must be 0. So we get 2 sine x plus 1 equals 0, or this one equals 0. Sine x minus 1 equals 0. And now we're down to two very simple equations that we can solve like we did in the previous lessons. So that's the extra step here, getting down to these equations by factorizing. Okay, so this one here, first of all, this one's a bit more familiar to us. So I get the sine x by itself. So I get the 2 sine x is equal to minus 1. Subtract 1 from both sides. Okay, and then divide across by that 2 there. I get sine x equals minus a half. And there you go. There's an equation exactly like the one we did 2 lessons ago. Okay, just a very simple equation. There isn't even a number for the x, so we're in business here. All right. So again, I'll do the usual with this one. Okay, so I'll remove the word sine. Let me get my reference angle first of all. So x then is the inverse sine of a half. Remember, I can ignore the minus sign. Okay, and inverse sine of a half. We want the answer in degrees here. So inverse sine of a half is 30 degrees. There's my reference angle. Now, whereabouts in the circle are we? Well, because we're dealing with sines, my circle looks like that. So there are pluses, there are minuses. And because we've got a negative sine value here, it's these two quadrants down here are my two winners. Okay, so we're going to say that one of the values of x is 180 plus 30, which is 210. Remember, in the third quadrant, it's 180 plus the angle. And then the other one will be 360 minus the angle. So it's 360 minus 30, which is 330, right? So there's two solutions to this equation here. They're the two we get from this equation. From putting this one equals 0. There's two of the possible answers. Okay, so 210 and 330. Now, what about this one here? Sine of x equals 1. Now, what I would normally do if I'm dealing with sine of x, sine, cosine, or tan of x equals 0 or 1 or minus 1. If I'm dealing with the zeros and the ones, you can actually do that using the graph instead, or a table on page 13. It's a bit messy if I try to go this way here, because I end up with angles that are 90 or angles that are 0. And how do you put an angle of 0 or 90 into a quadrant? That can be a bit confusing. Okay, so if you're dealing with the number on the right-hand side being 0 or 1 or minus 1, you can do it using your graph. So if you think about what does the graph of sine x look like? Remember, it looks like this. Graph of sine x looks like that. Goes up in an n, goes down in a u like that. And the period is 360, that way. So remember, that's 180 there in the middle. And then that's 270, and then that's 90, right? So where's sine x equal to 1? Well, there's 1 there. Remember that the sine graph goes up as high as 1 and down as low as minus 1. So where is sine of x equal to 1? Here, 90 degrees. So 90 degrees is the answer for that one there. And there's my three solutions. My three values for x are 90 degrees, okay, this one here, 210, and 330. So the one solution I got from this equation, that one, and the two I got from this equation, that one. Now, if you're not comfortable using the graph, if you look at your formula booklet on page 13, you'll notice we've got this table here, okay, which deals with the major angles. You can see the ones and the zeros are in here. So in this one here, you've got the ones and the zeros, okay? So you can see that if you're dealing with zeros and ones, okay, they're in this table here, right? So in this case here, if I'm trying to find, look, I'm told that the sine is equal to 1. So I know that the angle I'm looking for, the sine of the angle is equal to 1. So if I go to the sine line here, there it is there. And where's the number 1? Here it is. Okay, you can see there's the number 1 there. And go up, you can see there's your angle, 90 degrees. So if you don't want to do it using your using the graph, if you're dealing with zeros and ones, you can find those on page 13 of your formula booklet. So there's my solutions for that equation there. Okay, so here's the question then on the next page, on page 262. So we've got 2 cosine squared a equals cosine a, and again, we're solving between 0 and 360. So again, when I'm trying to solve an equation like this, and when I'm not sure how to solve an equation, my plan is always get everything onto the same side. So you've got a 0 on the other side and factorize. not just in trigonometry and algebra, calculus, anywhere you meet an unusually difficult equation to solve, try that. Put everything on the same side, so you've got a 0 on the opposite side, and then try and factorize the side where all the terms are. Because if you can write the left-hand side as two things multiplied together, if that equals 0, one of those things equals 0, so you'll end up with simpler equations to try and sink your teeth into. So I bring the cosine A across here. I'll get 2 cosine squared A minus cosine A equals 0. Now you can see I can factorize that quite easily, because both of these terms here divide by cosine A. If you want to replace the cosine with a letter, say you've got, for example, 2a squared minus a equals 0, replace the cosines with a. You can see that both terms here are divisible by a. You can pull a outside the bracket, so you don't need to write that down, but you can do that if you need to have you visualize it. But both these here divide by cosine. So if I take cosine a outside a bracket, divide that by cosine a, I get 2 cosine a. And divide this by cosine, I get minus 1. It doesn't disappear, you're dividing. So minus cosine A divided by cosine A is minus 1, and that's equal to 0. And now we're in what could only be described as business. Right? You can see we've broken it down into two simple equations now. So if these two things multiply together to give me 0, then either that must be 0 or that must be 0. Okay? So cosine A equals 0 is one equation. All right? And the other equation then is 2 cosine A minus 1 equals 0. So let's kind of rearrange that one. Add 1 to both sides here. We get 2 cosine A is equal to 1. Then divide by 2. Cosine A is equal to 1/2. And there's two equations I can solve now to find my values for A. So notice this one here again. There's the one with the zeros. Okay, so there's a 0, 1. So if I want to, I can take a trip to page 13 of my formula booklet. So there it is there. And you can see cosine equal to 0. So if I go to the cosine line of the table here, right, where are the zeros? Well, there's a 0 here and a 0 here. So the two answers you can see are 90 degrees and 270. So the two solutions to that equation there are 90 and 270. So this one here, if cosine A equals 0, that means A is 90 degrees and 270 degrees. Or remember, if you want to do that using the graph, remember the shape of the cosine graph, it's the one that looks like that. Right? So that's 360 there. There's 180 in the middle. And there's 90 and there's 270. Okay, so the two numbers in the middle there are where the graph hits the x-axis, where you hit the 0. Okay, so you can do it using your graph or page 13 if you're dealing with ones and zeros. Okay, because they can be a bit tricky, because if you try to get the inverse cosine, inverse sine, inverse tan of of those angles, zeros and ones, you get angles that don't fit into quadrants quite easily. All right, so in this case here, there's the two solutions to that equation. So the other one then, cosine A is equal to 1/2. Well, we're back in familiar territory with that one. That's an equation like the ones we've been solving already. That if I just say, look, A is the inverse cosine of 1/2. Okay, and my calculus in degree mode because I'm looking for a degree answer. And that gives me a reference angle of 60 degrees. So the reference angle there is 60. So what does my circle look like? Because I'm dealing with cosines here. Remember, cosines, they're the positives, they're the negatives. So because you've got a positive value here, okay, it's this quadrant here and this one. Okay, so the first and fourth quadrants. So A will be 0 plus 60, which is 60 degrees. And then A in the fourth quadrant will be 360 minus 60, which is 300 degrees. So there's your four answers: 90, 270, 60, and 300. There's four different answers for that one there. Okay, so it might be just worth pausing the video there. Maybe try the one on page 263 yourself, the third question. Just see if you can get your head around that. Little bit trickier, okay, but just see if you can get your head around that before we look at kind of two slightly trickier variations to finish off the class. So if you look at this third question here then, so everything's already on the left-hand side. So can I factorize the left-hand side? Yes. By highest common factor. You can see both terms there divide by cosine theta. They both get a cosine, so I can pull cosine theta outside a bracket like that, all right? And if I divide this by cosine theta, I just get root 2 sine theta. And again, if I divide that by cosine theta, it doesn't disappear. Cosine theta divided by cosine theta is 1. Okay, that's equal to 0. There we go, all right? So you can see then, if I put each of those, so if these two things multiply together to give me 0, either that must be 0 or that must be 0. So we get cosine theta equal to 0, or we get root 2 sine theta plus 1 equals 0. And there's two equations I can solve. And notice again here, there's another equation where we've got a 0 involved. It's a cosine one. So if I just want to have a quick look at my table on page 13, so we're dealing with cosine here. You can see that line there, and there's the zeros. And we're looking for the radian answer this time. So there they are there, pi over 2 and 3 pi over 2. So I can grab those two from my, my formula booklet. Okay, so the solutions for this one here are pi over 2 and 3 pi over 2. There's two possible solutions to this equation here. And then if I just want to tidy up the other one, again, we'll subtract 1 from both sides. I get root 2 sine theta is equal to minus 1. And then divide by this number here, I get sine theta is equal to minus 1 over root 2. And there's another one of the equations we can now solve as we've done before. Okay, so we'll start off by taking the inverse sine. So theta is the inverse sine of, remember, I can ignore that minus sign. That only tells me which quadrants the numbers I'm looking for are in. So the inverse sine of 1 over root 2, again, we're in radian mode. So you're calculating that's a quarter pi, or pi over 4. Is my reference angle there, okay, to get me started. And then, because I'm dealing with sines, all right, what does the circle look like? Plus, plus, minus, minus. So because it's a negative sign value, it's these two quadrants, quadrants 3 and 4. So it's going to be pi plus the angle, and 2 pi minus the angle will be the other two solutions. So theta will be pi plus pi over 4, which is 5 pi over 4. And then theta is equal to 2 pi minus pi over 4, which is 7 pi over 4. And there's my 4 solutions. Okay? And if you want to write on the bottom of very bottom of the box the 4 solutions, one after the other, you can do that. It's not absolutely necessary, but just to make sure you have them all, there are 4 different answers there. Okay? Now, last two then, if you look at the one on the next page, now this is a trickier example. So we're asked to solve this equation here, right? So we've got cosine 2 theta plus sine theta equals 0. And again, we're doing this between 0 and 360. Now, that's a very difficult example, this question here. People will find this one very hard going, because I've already got everything on the left-hand side, but those two terms have nothing in common. There's no way I can factorize this, so I think I'm in trouble. Okay, I'm not sure how to go about that. Okay, so the workaround here, I know what I'm trying to do here is to factorize the left-hand side, but at the moment I can't. Okay, because the two terms have nothing in common. So can I rewrite either of these two terms here using my formulas from my formula booklet to make that possible? Okay, and the answer is that I can. All right, that if you just if I just look for a second, that if I go to my formula booklet, okay, on page 14, right? So notice the formula booklet there on page 14. That you can see here on page 14, about halfway down here, on the left-hand side, I've got this formula here. Cosine 2a is equal to cosine squared a minus sine squared a. Okay, I've got that one there. Or if you want better again, I've got this one down here, right? So I've got a couple of options in the case of this question here that I can use to rewrite, because in both cases here, I can rewrite what cosine 2a is equal to, okay, using these formulas here, right? So it's not essential that I know exactly what's on page 14. So when I open page 14 there, it's more in hope than expectation. It's not like I know exactly what's going on down there. I'm going to see if I can find a formula that might help me do that. So do you see that formula that's kind of in the bottom left-hand corner of page 14? It looks like this. It says that sine squared a, okay, is equal to a half 1 minus cosine 2a. Okay? So that's our formula, a formula that's on the bottom of page 14. Now if I just rearrange that, let's multiply both sides by 2 to remove the fraction here. I get 2 sine squared a is equal to 1 minus cosine 2a. I'll just swap these two sides here. So bring this across here, I get cosine 2a over on the left. And bring this across here, I get 1 minus 2 sine squared a here on the right. And I can now put this in here. And now the equation will only contain sines, and now we're in business. Now we can solve. Okay? So you can see if I swap that out there, I get 1 minus 2 times sine squared a plus sine a is equal to 0. And maybe if I just multiply everything by -1, just to change all the signs. So I multiply this by -1, I'll get 2 sine squared A. Multiply this by -1, I'll get minus sine A. Multiply that by -1, I get -1 equals 0. And notice that's the equation we did back in the very first question of the lesson. So that's the very same equation we solved back on page 261. So I don't need to solve that again. The key thing is just how I get down there. So that equation now we can now solve because it only contains signs. So when you're dealing with one of these very tricky equations, your first thought is to factorize the left-hand side. If you get one like this where that's not possible, feel free to take that personally. Okay, that's a very, very difficult question to be throwing in your direction. But what you need to be trying to do there is, let me see if I can rewrite any of the terms on the left-hand side using formulas from my formula booklet. Just open up the formula booklet, page 14, 15, probably page 14, and see if you can find something that will allow you to rewrite one of the terms. In this case here, I was able to rewrite cosine 2 theta. And if you do that, then try and factorize and finish it out from there. Right? So as a final example there, if you look at the question on page 265, really tricky one, just see what you make of that, and then we'll do that in a second just to finish up this lesson here. Okay, so let's have a look at this car crash of a thing here, all right? So we're asked to solve that equation there, sine 2x minus cosine x equals 0. So again, everything's already on the left-hand side, so I know my plan here is to try to factorize the left-hand side, but the left-hand side doesn't factorize. Those terms have nothing in common. And there's different kind of ratios of sine and cosine there. So I don't see any immediate factorization there. So my plan is to see if I can rewrite something here, right? So can I use one of my formulas from page 13, 14, 15 to rewrite one of the terms there on the left-hand side? So if you look at page 14 of your formula booklet, the same page we had a look at a moment ago, you can see here about halfway down the left-hand side, there's a sexy looking formula there, see it? Sine 2a equals 2 sine a cosine a. So the sine 2a on the left-hand side of my equation, I can rewrite using that. All right, so I'll give that a try there. That looks like that might be our winner. All right, so let me just see if that helps. Okay, by doing that. If not, I'll go back and have another look and see if I can find something else. But let me see what happens there. So I know from page 14 that sine 2x can be written as 2 sine x cosine x. Now, does that help my cause? Yes. Because you can see now, when I've written it that way, now the two terms on the left-hand side can be are both divisible by cosine x. They have a cosine x in common, now I can factorize. So that's the idea here. When you're dealing with these really complicated trig equations, you're trying to factorize the left-hand side and put each factor equal to 0. Because that should give you two simpler equations you can solve, like the ones we've been doing in the previous lessons. But if you can't factorize directly, have a look at the terms on your left-hand side and see, can you rewrite one or both of them, okay, one or more of them, using formulas from page 13, 14, 15 of your formula booklet, and then factorize. So in this case, I can now. Let's just pull the cosine x outside a bracket there. Divide this by cosine x, I get 2 sine x. Divide minus cosine x by minus cosine x, I get -1. Remember, it doesn't disappear, I'm dividing. And now, Robert's your mother's brother. We're in business now because you can see I've got the left-hand side factorized, two things multiplied together. Those equations I can solve, okay? So cosine x equals 0 is one equation, and then 2 sine x minus 1 is the other. Now this we've already kind of dealt with. I can go to page 13 of my formula book where that table is, or I can draw the graph. But the two values for that is 90 degrees and 270. We've kind of dealt with that already. That's the table on page 13. But this guy here, if I add 1 to both sides, I get 2 sine x equals 1. So divide both sides by 2, you get sine x equals 1/2. And there's one of our good old-fashioned trig equations to solve there. Not too hard. Just remove the sign there to get our reference angle. So x is the inverse sine of 1/2. And because we're dealing with degrees here, we get that x equals 30 degrees. And because it's sines we're working with, which quadrants are my answers in? Remember, the circle looks like that for sines. Okay, the first two quadrants are positive, the second two are negative. So because you've got a positive sine value here, it's the first two quadrants here. So it's 0 plus the angle and 180 minus the angle are my two solutions there. So x will be 0 plus 30 degrees, which is 30. And x will be 180 minus 30 degrees, which is 150. Okay, so there's the four solutions to this equation here. 30 degrees, 150 degrees, 90 degrees, and 270. And if you want to write the four of those side by side at the bottom of the page, just to make sure you're clear that you got all the solutions, and that's what they look like. So they're very difficult equations. They're not very common at all, but that's what your strategy would be if you're dealing with those. Right? So we don't have very much left to look at now in the trigonometry. In the next lesson, we're going to take a look at working a bit more with those formulas from page 13, 14, 15, and 16. We'll have a look then at how you prove the ones that are necessary as proofs on the Leaving Cert course. And then we'll finish up by doing a little bit of work on identities to bring the topic to a close in a couple of lessons' time. Okay, so we'll start working with the formulas a little bit in the next lesson.